Hi everyone. In this video, I'm just going to show you 3 ways that I generate secure passwords for my social media accounts, all my logins for whatever services I use, and also my digital mobile radios that support AES 256-bit encryption. So one of the ways that I generate secure passwords is with a Windows app called KeyGen app. It's right here. It's a very simple app. You can select what kind of characters you want, so numeric, uppercase, lowercase, and special. You can select the length of the password, how many characters it is, and you can either turn on or off character redundancy. So if you turn off character redundancy, it will prevent, for example, the same character appearing 4 times in a row or many times in the password string. If you leave it checked, then there is a possibility that there could be repetitive characters. So you always want to turn that off. Let's just do one that's numeric, uppercase, lowercase, and special. And I always make my password 64 characters. So let's do generate a keygen. And as you can see, there we go at the top. There's the thing. You can copy it, paste it, put it into your Google Password Manager, whatever. And if you press generate a keygen again, it just keeps regenerating new ones. You can again change that too. If I want to turn off lowercase and special and just do numeric and uppercase, then I can do that. And as you can see, it changes. So there's that. Then I have this app called Combat Keygen. It's a Russian app. That's why there's all these question marks, because it can't read Russian. You can generate passwords between 64 and 1024 bits. I don't know what all the buttons do at the bottom. I know this button right here will regenerate passwords, and this button here will copy them. You can generate up to 16 passwords at a time. So there's me doing a 64-bit, 128-bit, 256-bit, etc. So let's say I do 256 and I click this button, it'll change the password. Change the keys repeatedly, and then if you press this, it'll copy them. And then the last way I generate passwords or keys, whatever you want to call them, is with Python algorithms. As you're about to see, I have about like 15 different Python algorithms. They're all, each one is slightly different. Some of them are not as good as others. I've kind of been playing around and tweaking things and adjusting things. So I'll show you the one that I've found to be the strongest based on doing calculating the entropy, the chi-square value, and histogramming at least 1,000 outputs to see the distribution of each character. So that will be this one. It uses Argon 2 for key derivation. So it asks you to enter a password. So if you type in a password like hello123 or QWERTY123, then your password's not going to be as strong. When it comes to password-based key derivation, the stronger the seed password, the stronger the encryption key that gets put out. So I just like to put my finger in circles on the keyboard, going both ways like this, run my fingers back and forth on the numbers, top row, middle row, bottom row, side to side, kind of like that. And then I hit enter, and now you can see it's generating the keys. It's going to generate 100, 100, and 100, 256-bit keys. Doesn't take that long. As you can see, we're already at 90, and now we're done. Now, if you wanted a shorter one, you can do a 128-bit key. Hit enter, and there you go. Now it's generating 128-bit keys. And there you go. We're done. Hit enter to exit. So you can see I have some other ones. Some are slower than others. This one I believe is slower than the Argon 2 one. Yeah, as you can see, that's significantly slower. But they're still all good. But I'm just going to show you the histogram that I got from analyze two. I got 2 histograms analyzing 1,000 outputs of the Python script I just showed you. So here's one of them. So as you can see, each character is essentially almost exactly the same um, um, uh, amount of times that that character occurs in the password, meaning there's an equal probability of each individual character occurring, and there's no bias towards a particular character or value or whatever. And then another one that I did that shows percentages and numbers. You can see that the difference between the lowest, which is 6.08%, and the highest, which is 6.39%, that's not that much. That's pretty damn good. And as you can see, it's very uniform, so it's very secure. So that's it for today. Hope you learned something from the video, found it useful or whatever. If you have any questions, drop them in the comment box. See ya.